All right, so now that we know how to plot polar coordinates, we want to start to do some conversions. So again, you're going to want that cool little handout that I gave you that tells you how to get back and forth between the two sets. And so we're going to start off with the polar coordinates of a point are given. So we have 10 comma 5 pi over 6. And I want to find the rectangular coordinates of this point. So remember that this is r theta. And now I know that if I want x, I can use r times the cosine of theta to get x, and I can use y will give me to get y, I can use r times the sine of theta. So for my x coordinate, I'm going to have r cosine theta, which is 5 pi over 6. So I get 10 times, what's the cosine of 5 pi over 6? It is negative root 3 over 2. So 10 times negative root 3 over 2 is going to give me negative 5 root 3. So in rectangular coordinates, my x and my y are going to be negative 5 root 3, and now we need to find y. So your y coordinate is going to be 10 times the sine of 5 pi over 6, which gives me 10 times 1/2, which is going to give me 5. So your radius times the cosine or the sine of the angle that you're given. So there are my Cartesian coordinates here from my polar coordinates here. So another one, I've got negative 5 comma pi over 4. So I've got negative 5 at pi over 4, and this one is slightly different. In this one, I had a positive radius and I had a positive angle measure. Well, I got a negative radius. So I should probably find the corresponding point, okay, which means I would go out 5. I would swing up to pi over 4, and then I'm going to slice through to, this would be 5 pi's over 4. So a corresponding point is 5 and then 5 pi over 4. So let's try both of them. If I have x is, let's try the top one first, I get negative 5 times the cosine of pi over 4, which gives me negative 5 times root 2 over 2, which gives me negative 5 root 2 over 2. Okay, so let's get our y coordinate. So I've got negative 5 times the sine of pi over 4, which gives me negative 5 times root 2 over 2, which gives me the same coordinate. So the coordinates just happen to be the same. Now, let's try it with this one. So if I have, same problem, I'm going to have x times 5 times the cosine of 5 pi's over 4, which gives me 5 times negative root 2 over 2, which gives me the same x coordinate. So if I use y, is 5 times the sine of 5 pi over 4, that gives me 5 times negative root 2 over 2, which gives me the same y coordinate. So even if we didn't switch it, it's still going to work out because these coordinates will land you at the same point. So your Cartesian set is going to be a negative 5 root 2 over 2 and a negative 5 root 2 over 2. So let's try a few more. I'm going to try and squish this into one video. So if I have a rectangular coordinates are negative 1, 0. So I'm given rectangular first of all. Okay, so I'm not in polar. And I want to figure out what that is in polar. Well, if you've got quadrantal angles, they're going to end up being a whole lot easier. So in other words, points on the x-axis or points on the y-axis are going to be really, really easy to figure out. Because if I want to get to this point, Well, how long is that point? That point is 1 unit, which means if I want to convert it, my radius will be 1. And then how far over do I swing? I swing over to pi. So your radius will be essentially given because it'll be the length of whatever it is on the axis, and then tell me how far to swing to get there. Okay, so what if I have negative 4, 4? Okay, so the rectangular coordinates are negative 4, 4. So that's my x and my y, and I want to know what the Cartesian coordinates are. That is the Cartesian. I want to know what the polar coordinates are, and I am told that r is positive, and I can be anywhere within 2 laps of the unit circle. So my theta can be between negative 2 pi to positive 2 pi. Okay, so I can either go backwards a lap or I can go forwards a lap, either way, but as long as my radius is positive. So first of all, plot your point. So I'm at negative 4, 4. So I'm in quadrant 2. And so if I recall, I need to get my radius. So I am going to draw my triangle. So I'm at negative 4, 4, and using Pythagorean theorem, we get 16 plus 16 is r squared. And so 4 root 2 is going to be r. Okay, just using Pythagorean theorem. So I find out that my radius is 4 root 2. Now what I would like to do is find out if this is a benchmark ratio or a benchmark angle. So I want to find, remembering that you're in quadrant 2, you can take the sine or the cosine of that angle. And then find out if it results in a benchmark ratio. So let's just do the sine. So the sine of that angle is going to be opposite over hypotenuse. So I get 4 over 4 root 2. Those reduce to 1 over root 2. And when I rationalize, I get root 2 over 2. So in quadrant 2, what's the angle measure that produces a sine ratio of root 2 over 2? And that's going to be at 3 pi over 4. So what I have is a radius of 4, I have a radius, let's go over here in a different color ink, of 4 root 2. And then where does sine give you a ratio of root 2 over 2 in quadrant 2? That happens at 3 pi over 4. So that's one set. Now I was also told I could go backwards. Okay, so as long as my radius is positive, so just to give you an alternative, I could have dropped down, if this is 3 pi's over 4, a full lap is 8 pi's over 4, so I must have dropped down 5 pi's over 4. So I can go backwards a lap, or partial lap, to get there. All right, so let's do another set. I have 5 root 3 comma 5. So I'm in quadrant 1. I am told, hang on, I'm reading. Use angle measures that are bigger than 0, so positive angle measures, and less than 2 pi. So my theta needs to be between 0 and 2 pi. But I don't care about my radius. So my radius can be positive or negative. So let's go ahead and find both sets. So first of all, remember that this is an x and this is a y. We converted to r theta. So we're going to build a triangle first. So I know that I am at 5 root 3 for my x, and I am at 5 for my y. So I'm in quadrant 1, build a triangle. So using Pythagorean theorem, I get 5 root 3 squared plus 5 squared will be my hypotenuse, or my radius squared. So 5 times 5 is 25. Root 3 times itself is 3. And that gives me 25. So r squared is 100, which means that r is 10. Okay? So now, is this a benchmark ratio? So again, coming off of theta, I'm either going to choose the sine or the cosine and find out, just because those are benchmark angles and ratios on your unit circle. So I'm going to use the sine of theta is 5 over 10, which is 1/2. So in quadrant 1, where does sine have a ratio of 1/2? And that's going to occur at pi over 6. So my radius is 10. Okay. Radius is 10. And my theta is at pi over 6. Now, just for kicks, let's do it because as long as I'm within 1 lap of the unit circle, it's okay. So let's use a negative ratio, which means I need to come over here. And then, I said negative ratio, negative radius. So I need to come over here and then slice back through. So first of all, I know that my radius is going to be negative, but then where do I need to go? So if this is 1 pi over 6, I need to drop down a pi over 6 as well, so that it's symmetric, which is not drawn to scale. So I needed to drop down a pi over 6. And so that means that this is 7 pi's over 6. Okay, so what does that mean? I'm going to come out 10. I'm going to swing out to 7 pi's over 6. And then I'm going to slice through the pole and I'm going to hit that point that I'm looking for. So I've got 2 different options for my answer. All right, so now what we want to do is start looking at equations. So what I have first of all, and you're going to be told for the most part, unless it's multiple choice, what format this needs to be in. So it'll be either equal to r squared, or 0. And it will be specific on how it tells you. So what I have is a 7x squared plus a 7y squared is a 10. And what I'm comparing it to is these over here. Okay, so these 2 will come in handy. But these specifically are going to help with equation conversion. So I do notice if I got an x squared and a y squared, it'll be r squared. So if I divide everything by 7, that'll give me x squared plus y squared is 10 sevenths. And now I can swap this out for r squared. So my final answer in polar form is r squared equals 10 sevenths. Now, why didn't I take a square root of both sides and do a plus minus? This is the equation of a circle. Okay. And since it's not a function, I'm just going to leave it in terms of r squared. All right, so let's try it again. I have x squared is 3y. X squared is 3y. So I know how to swap out an x. I do not have a y squared, but I know how to swap out an x, and I know how to swap out a y. Okay, because I know that x is r cosine theta, and I know that y is r sine theta. So it might help for you to see it as this. I've got x squared is 3y. Okay, so now I can just swap out my x. Well, my x is r cosine theta, and my y is r sine theta. And so I need to go ahead and distribute this square. So I have r squared times cosine squared theta equals 3r sine theta, and then set it equal to 0. So I'm going to subtract 3r sine theta from both sides. And I get r squared times cosine squared theta minus 3r sine theta is 0. Okay? And so again, go back up here. If I divided both sides by 3, you would have y equals x squared over 3, which is a parabola. So this is a parabola. All right, I've got 11xy equals 1. So 11xy equals 1. So I'm going to go ahead and substitute in. I know what x is, and I know what y is. So I have 11 times r cosine theta times r sine theta is 1. And then I can combine like terms, and I can go ahead and get 11 r squared sine theta cosine theta is 1. And then I notice I can actually use an identity here. So if I use my Pythagorean identities for a double angle theorem, then I will realize that 2 sine theta cosine theta equals the sine of 2 theta. So we might as well kind of throw that in there. But here's the issue. I need a 2 right here. So if I multiply by 2, I'm going to balance with a 1/2. So really and truly, all I did was multiply by 1. But I'm going to utilize this in a double angle formula, which means that 1/2 is going to carry along. And that little trick right there is going to help you in calculus. So I end up with 11/2 r squared, and then this part turns into the sine of 2 theta equals 1. Okay, so now where'd the 2 go? The 2 is in here. Okay, so this is an equivalent expression because I used an identity to go from here to here. So even though it's not obvious, that 2 is still there. All right, so, and again, what would this be if you graphed it? You would divide both sides by 11x, and you would have y equals 1 over 11x, which would look like that graph right there. All right, so I have x equals 7. So that's a vertical line that slices through the x-axis at 7. Well, do I know how to convert it? I do, because I know what x is. So x is r cosine theta is 7. And you're done. Okay? So I'm going to go ahead and finish this out. So this is going to be a slightly longer video than normal, but it's okay. We're almost done. So I've got r equals 9 cosine theta. And if you'll notice, I know what r squared is, but I don't have an r squared. And I know what r cosine theta is, but all I have is a cosine theta. So I'm missing an r on both sides. So I can multiply both sides by r to generate what I need. So now I've got r squared equals 9r cosine theta. And what does r squared equal? Well, r squared equals x squared plus y squared. And then I have equals 9. What does r cosine theta equal? It equals x. So one of the things you want to pay attention to is if you need an r squared, you can get it one of 2 ways. Either multiply both sides by r or square both sides. Okay, so it works both ways. So if I want to get this thing equal to 0, which I do, I'm going to have x squared minus 9x plus y squared equals 0. Okay, so what if I have this? I have r squared equals 11 cosine theta. Okay, so side note, this is a circle that got shifted to the right. This is a circle that got shifted to the right. So I have this now. I got my r squared, but I'm missing an r here. So that's kind of sort of an issue. So I need an r on both sides, and that looks like it's going to mess me up here, but have no fear, we'll figure it out. So I'm going to multiply both sides by r. Okay, so this gives me an r to the third. Well, I don't have a way to deal with r to the third, but I can square both sides. Okay, so again, this is another strategy. If I square both sides, now I'm going to flip-flop this. Remember that this is x to the 6th, or sorry, r to the 6th. But I can invert these two exponents. So really and truly, this is going to be an r squared to the third. Okay, and this is going to be a 121 r cosine theta squared. So square your 11, square your r, square your cosine. Well, now I know that this is x. And I know that this is x squared plus y squared. So swap out your r squared for an x squared plus y squared to the third. And that's a 121 x squared. Okay, and we're supposed to set that equal to 0. So I am going to subtract 121x squared from both sides. So I end up with x squared plus y squared to the third minus 121x squared is 0. All right, so we've got 2 more until we're done with this section. So like I said, this video is going to be just a little bit longer. I have r equals 20 over 1 minus cosine theta. Okay. And so first of all, I notice that my cosine's in the denominator, and I don't like that. So the first thing I'm going to do is make him be in the numerator. So I'm going to multiply both sides by 1 minus cosine theta. So it's going to reduce over here, and it will appear over here. And now I'm going to go ahead and distribute that r. So I've got r minus r cosine theta equals 20. So I've got this x here. I wish that was an r squared. So that kind of sort of informs me, get this thing over to the right. Okay? I like him, get him over to the right, because 20 is friendly as well. So I'm going to add r cosine theta to both sides. And now I can square both sides, and that's kind of like what we did a while ago. Okay? So I'm forcing things to happen. So I'm going to have an r squared equals r cosine theta plus 20 squared. So I'm going to go ahead and FOIL him out. Remember, you are foiling because that is the same thing as r cosine theta plus 20 times r cosine theta plus 20. So that's going to give me an r squared equals r squared cosine squared, which is going to be r cosine theta squared. And I'm going to have plus 20 of those things plus another 20 of those things gives me 40 of those things. And then that's going to be plus 400. So if you'll notice, I know how to swap this out, I know how to swap this out, and I know how to swap this out. So I have an x squared plus a y squared equals an x squared plus a 40x plus 400. And I want that to be equal to 0. So I'm going to subtract x squared from both sides, which means those are gone, which is fine. Subtract 40x and subtract 400. So I get, those are gone, y squared minus 40x minus 400 is 0. So the last one, we're going to play with airplanes. All right, so what do I know? I have at 10:15 a.m. So at 10:15 a.m. You cannot see. Okay. At 10:15 a.m., a radar station detects an aircraft at a point 80 miles away and 35 degrees north of due east. So here is my radar station, and I've got an aircraft 35 degrees north of due east. So here's due east, swing at 35 degrees north. And there is my aircraft, and I notice that it's 80 miles away. Okay, at 10:25 a.m., so at 10:25 a.m., the aircraft is 110 miles away and 15 degrees south of due east. So I'm going to swing this down 15 degrees, and it's now 110 miles away. So this is 15 degrees south of due east. All right, so I want to do this in rectangular coordinates. I want to do this in, polar coordinates. So I'm going to do polar coordinates first. So where is the first airplane? So ignore all this stuff down here. Well, the first airplane, I know a radius, and I know a theta. Okay, so I have my radius is 80 degrees, 80 miles at 35 degrees. So that's r theta. My second aircraft is at a radius of 110, and then I had to drop down 15 degrees. So he's negative 15 degrees. Okay, so now I want to put these into rectangular. So for rectangular, my x is going to be 80 cosine 35, and my y is going to be 80 sine 35. And when I put that in my calculator, first of all, give me a second. All right, go back there, and I need to be in degrees. So I have 80 times the cosine of 35, and I've got 80 times the sine of 35. So the first coordinate is going to be 65, 53, and the second, or the y coordinate, will be 45, 89. So this becomes 65, 53, comma, 45, 89. So this is r theta, this is xy. So for this set of polar coordinates, I've got x equals 110 times the cosine of negative 15 degrees, and y is going to equal 110 times the sine of negative 15 degrees. So in my calculator, I've got 110 times the cosine of negative 15 and 110 times the sine of negative 15. Oops, sorry, that's wrong. Okay, so I have the sine of negative 15. So my x coordinate is going to be 106.25, and my y coordinate is going to be negative 28.47. So my x is 106.25, and my y is a negative, because we're dropping down, is a negative 28.47. Okay, so I've converted from polar for both airplanes into rectangular for both airplanes. And the final question is, what's the speed of the aircraft in miles per hour? So what is the speed of the aircraft in miles per hour? Well, I better figure out, first of all, how far he went. Okay, because he started here, and 10 minutes later he was here. So I do not have a completed ratio, but I do know that this angle is 50 degrees total. Okay, 35 and 15 is 50. So I can use the law of cosines. So I've got a squared, I got a squared equals b squared plus c squared minus 2bc times the cosine of a. So a squared is what I'm looking for. So that gives me 80 squared plus 110 squared minus 2 times 80 times 110 times the cosine of 50 degrees. But I don't care what a squared is, I want to know what a is. So I'm going to take the square root of both sides, making sure that you are in degrees. Am I in degrees? Yes, I am. Okay, take the square root of 80 squared plus 110 squared minus 2 times 80 times 110 times the cosine of 50 degrees. And I get that, and I got 84.776. So 84.776. That's how many miles he went in 10 minutes, because he went from 10:15 to 10:25. I want to know how many miles he goes in an hour. So I'm going to use that 84.776 over 10 minutes will equal x over 60 minutes. Okay, that says 60. So I'm going to cross multiply. So I get 6 times that will equal 10x. So I have 60 times that initial decimal, so the answer times 60. And I'm going to divide that by 10, and I round to the nearest tenth, and I get 508.7 miles per hour. 508.7 miles per hour. And that's it.